All right, I've got 12:02, so I think we can probably go ahead and get started, and I'll do all the introductions before we get into the content itself for the late joiners. So thank you everyone for joining the quarterly Livepeer Transcoder call. As a note, this is being recorded and it's being live streamed at crypto.livepeer.tv. So feel free to participate. Just know it's recorded. People will be watching back later. And those who don't want to participate are welcome to watch the live stream or check back in on the recorded content. So we used to do community calls once every 2 weeks, and it was a great opportunity for everyone to be in the same place at the same time and ask questions and hear what's going on. But we got a bunch of feedback and did some thinking on how to make them more useful for everyone in the community. And what we settled at is having specific calls targeted at specific groups of users who have more specific interests to have really great helpful content for those groups so that we can focus the conversation, the discussions, the guests, and make it really helpful and effective for the community. And so this is and we'll do this less often, but it doesn't mean we're not accessible. We're still always around and happy to hop on a call or a chat if you want to catch up or learn more frequently. And so this is the example of the call focused towards people who want to run infrastructure on the Livepeer network. We called it the quarterly transcoder call. As we launch the Streamflow upgrade, the kind of names of the roles are updated to reflect orchestrators and transcoders, likely run by the same people. But the point is, if you want to run infrastructure on the Livepeer network that competes to win work and do video transcoding and earn fees, this is the call for you. And we want to make the content really helpful to everyone here so that you're well positioned to participate and compete well on the public Livepeer network. So what are we going to do today? I'm going to talk a little bit. We're going to show a bunch, and we'll have time for questions and discussion as well. So first, we're going to talk practically about Streamflow, and we're going to talk about running orchestrators and transcoder nodes on Streamflow. And we're going to have 2 demos. We're going to do first a kind of basic node operation overview that just shows at a high level some of the commands that you need to know, talk through some of the flags that might be important, trying to make it really practical for you to kind of learn what some of these configurations mean as you're running nodes. You're welcome to practice that on testnet before we go live on mainnet, of course. And then kind of the second topic and demo there will be talking about concurrently using your GPUs to mine cryptocurrency while you're actually transcoding video on Livepeer. I've done some early testing there. We're going to show a demo of this in action, and we could probably talk about the intricacies of that topic for a long time, but we'll have a kind of brief discussion and show some of the practical things that you need to test this out yourself as well. We can loop back and talk about bandwidth requirements and kind of pricing discussion around bandwidth and how you might want to price your service on the Livepeer network. And finally, at the end, I kind of just want to make a practical recommendation to how you might want to get started with running orchestrators, transcoders on Livepeer as it relates to this GPU transcoding, the mining, and the differences in Streamflow, because I think there's a big difference from what it takes to maybe compete to do this at scale, as there's tens of thousands of videos coming into Livepeer. That's not where we are today, but what might you want to do as the first step to learn how to do this and kind of grow as Livepeer demand grows as well. So I think that's the agenda. We have time for Q&A, and feel free to drop questions into the chat or interrupt me as we go. As well. This is really about everyone on the call. It's not a big presentation. It's meant to be as useful as possible for people who want to run on Livepeer. And I'm glad there's so many different people from different groups and organizations here on the call. Cool. Okay, so first thing that I want to note is Streamflow is coming soon. We haven't publicly, committed to January 9th, but it's a likely target that we've been angling around. The code is basically done and feature complete for the Streamflow release. We did a recent testnet upgrade and deployment, and probably have at least one more to do before going mainnet. But we're targeting this January 9th, Thursday on the second week of January, to do the Streamflow upgrades. It's a little over a month away, but it also feels pretty close with some of the year-end holidays coming up. So really excited about this. Been working for a long time. I know everyone's been waiting for it because this is unlock scaled usage on the network. So what is, for those of you who are operating transcoders on Livepeer today, one question is, what's the minimum viable thing that you have to do to be Streamflow compatible? And it's actually, on the surface, it's not that much. Basically, you have to prepare to upgrade your nodes and just upgrade the Livepeer software that you're running for the Streamflow release. Ideally, I suspect you would want to be available to time it such that sometime during that first round of Streamflow, you are able to upgrade your software. I don't believe, as it's built right now, you can deploy the new version in advance and have it seamlessly switch over. But again, this is basically just stopping one process, starting the other process, and you can certainly deploy it on testnet and be comfortable that you're up and running in advance as well. That's basically it. You have to learn a couple new flags for your node when you start it up, and potentially submit a transaction or two to the blockchain to kind of register the publicly accessible address for your node if you want that to change under Streamflow. But largely, there's not too much. So the minimum viable path is pretty easy, and you can continue doing this on your current infrastructure. And what happens in that minimum viable path, you'll continue to call reward and earn your inflationary LPT each day. So again, I emphasize this is the bare minimum, but I would say there's a caveat here. So this alone won't prepare you to win much work on the network. When we focus on the goal here, it's worth keeping in mind the goal is that you can transcode video profitably and earn fees for doing so, and that you're doing this at a cost-disruptive price to what the other transcode services on market actually are, the cloud services, the do-it-yourself prices on public cloud, you're deploying your own solutions. And so kind of the big mental shift is in the alpha, maybe you've been comfortable just, on a CPU-based setup, running your node to call reward once a day and coasting by, kind of earning inflationary LPT, and that's been helpful for bootstrapping the network, attracting delegation, maybe doing some light transcoding for single streams here and there. But Streamflow unlocks use at scale, and it doesn't mean there's going to be thousands of streams on day one, but we will be sending a lot of video streams through, and people will be testing the network, and you're going to want to see that you're well positioned to compete, to win the work, to transcode these streams, and do it in a way that makes you money, and makes still results in the network being really affordable to use for everyone. And so for there's more steps, and we'll talk about ideally the most cost-effective way to compete, especially in the long term, is likely to be running GPUs that can encode video effectively and also potentially mine cryptocurrency at the same time. And we'll talk a little bit about how to do that. So we're about to jump into kind of demos and walkthroughs for node operations and GPU mining. Before we do that, would anyone like to ask any questions about kind of this upcoming Streamflow timing or your role running infrastructure under Streamflow?
Hi, Doug. It's Chris from Streamflow.
Hey, Chris.
Hey, I was wondering how the active set is chosen, or is that not much of a consideration here?
So in Streamflow, the active set is going to expand from 25 nodes to 100 nodes, and it'll be the 100 nodes with the highest delegated stake who have also invoked the transcoder transaction to indicate that they want to be active transcoders. So it should be highly accessible initially because there's nowhere near 100 nodes to have active stake. And I would imagine that the kind of cost barrier to entry will remain very, very low for the immediate to medium term. We'll see how those dynamics shift as stake moves around over the longer term. But certainly anyone who is paying attention, who's on this call, who wants to run infrastructure and is willing to secure their work through a minimal amount of staked LPT or track delegation will have the ability to kind of compete as an orchestrator on the network in the early days.
Just a small note on the upgrade process. We will be putting out a short upgrade guide prior to the upgrade itself. So just keep an eye out for that for anyone that has that in mind.
Great, thanks, Shannon. And yeah, again, feel free to interrupt with questions or drop them in the chat as we go. We'll have time at the end, but to keep it moving, I'll actually kick it over to Yandin right now, who is gonna kind of walk us through, not a long walkthrough of the step-by-step of every command you need to do in order to run a node. That's all kind of in the getting started guide, the documentation, but mostly just to focus on some of the key configurations and commands that you might need to help clarify anything that's confusing in terms of setting up your node to run. So Yana, why don't you just kind of start driving, and I'll kind of interrupt for clarification. Others can as well as we go.
Sure. So I think I'm going to make use of this time to just highlight the general walkthrough and point at some of the relevant areas of the docs that someone that is trying to test things out on the testnet can go through. And then a lot of the steps are going to look pretty similar to what anyone that's running a transcoder today has seen on the V1 network. And I'll just highlight some of the additional flags that are different and provide a brief explainer. Probably won't go too in-depth, and then a more in-depth discussion can be held off for later on. So I'm going to share my screen. Cool. So right now, this is the page that I'm on right now is the Streamflow public testnet docs. So this is a separate section of the read the docs for Livepeer. And the first thing that you're going to want to do is pull down the latest release from the GitHub release pages. And one thing of note is that our Streamflow compatible releases are currently on a separate track from our mainnet compatible releases, since there's been a significant amount of breaking changes since the original mainnet compatible releases. So just make sure that you look at the release notes on GitHub to make sure that you're downloading a Streamflow compatible release. And we're currently on 0.5.1. The next thing that you're going to do for the first time is probably just do a quick start, where we're just going to try to run a few commands to get our node up and running. And this is going to ignore other details around other flags that you might want to configure in order to actually win work on the network, and it just seeks to get a node up and running. So I'm going to go to my terminal, and I'm currently on AWS instance. And in this screen session, I'm just going to run this simple command to get started, where I think the first flag is fairly self-explanatory, where we're going to connect to the Rinkeby network. So this is using a Streamflow compatible node. And we're going to connect to this set of Streamflow contracts that are currently deployed on the Rinkeby test network.
Hey, Anand, if you could make your font a little bigger in the terminal, it might help people. Thanks.
Yeah, is that better?
Yeah.
Cool. So the next two flags are something that some people might not be familiar with, but it's a separate orchestrator and transcoder tag flag. So as was mentioned earlier, we now have these two distinct roles within the Livepeer system, where we both have orchestrators and transcoders, where in V1, the term transcoder was used to describe both roles, and one person fulfilled both roles. But as a part of this architecture update, we now actually have both orchestrators and transcoders, where the orchestrator node you can think of as a sort of load balancing node. that receives work from the network and then is just going to distribute it across the transcoder nodes that are registered with it. So you can have multiple transcoder nodes all connected to the same orchestrator node, allowing you to horizontally scale pretty easily. But for the purposes of this demonstration, we're going to run this node with both the orchestrator and transcoder flag, basically indicating that we're going to run the orchestrator and the transcoder on the same machine. And you may not do this in practice when you're actually running at scale on the network, but this just gets you up and running pretty easily. And the last flag that's mentioned is the price per unit flag. So one fairly substantial change as a part of the Streamflow upgrade is the way that pricing is done on the network. So in V1, all fees were priced per segment of video transcoded. But in Streamflow, we've switched to this new metering mechanism where transcoding is actually metered based upon the amount of resources consumed by a transcoder node. And the way that we meter those resources is that we use this unit of measurement pixels, so the number of pixels that are actually transcoded. So for anyone that's familiar with the gas metering mechanism used for Ethereum, this is pretty similar to that, where in Ethereum, you have smart contract computation that's metered based upon the number of steps the computation takes. And then as you consume more steps, you have to pay more in transaction fees. Similarly, in Livepeer, as you consume more pixels as a result of the transcoding operation that you requested, your fee is going to increase. So the orchestrator is going to keep track of how many pixels are being transcoded, and then the fees that are charged are going to be based on the number of pixels consumed. So for this demonstration, we just set our price per unit to 1. And this is denominated in Wei. So we're just saying that for each pixel that we transcode, we're charging you 1 Wei. And you can configure this however you'd like. So running this command is just going to start a very basic combined orchestrator and transcoder node. And I think the main thing that's worth noting here is the public availability requirement. So if you look at the logs here, you can see on this line that I'm highlighting that the orchestrator node is listening on port 8935, which needs to be accessible to the public internet. And then the next thing that the node does is that given the public IP that this node is using and the public port that this node is using, it's going to try to connect to itself and ping itself basically to check if it's able to connect with itself over the public internet. And this is an important thing to mention. As a part of the Livepeer network, in order for you to actually receive incoming segments and incoming payments, you need to make sure that your port and IP are publicly accessible, or else you won't be reachable by other nodes on the network. So when you are getting started, you're going to want to make sure to pay attention to these logs to see if your orchestrator node is able to successfully ping itself and able to successfully connect with itself, or else if you keep your node running, you're not going to receive any requests from any other nodes on the network because you're not publicly accessible. So that's a very basic command just to get your node up and running. And the next thing that you're probably going to do is you're going to want to get some test ether so that you can actually submit transactions. And this is on the Rinkeby network. So your best shot here is to use the authenticated Rinkeby faucet that many people are probably familiar with if they've done Ethereum development. And once you have some test ether, you're going to want to get some test LPT as well, because in order to actually register as an orchestrator, you're going to need to stake some test LPT. So if you're following the docs, we have a section dedicated to this. And the easiest way to get some test LPT is to use the accompanying CLI wizard, Livepeer_CLI. And it's going to provide you with a bunch of options. One of them being to request some test LPT from a contract that's deployed on Rinkeby that's pre-funded with a bunch of test LPT. So we can take a look at that right now. And if I move into this separate screen session and open up Livepeer CLI, then I can see here that option 16, get some test LPT. I'll select that. And if I navigate back to my original screen session with my node, I can see that it just submitted an Ethereum transaction, and this should confirm shortly. And it is now confirmed. And if we go back to the node status, I probably should have showed this earlier, but you'll just have to take my word for it. But the LPT balance of this node was previously, the first number was 2, and now it's 3, because each request to the faucet will give you, I believe, 10 LPT to work with. And the faucet is also rate limited, so you can only perform 1 request every hour. So that's something to keep in mind as well. But usually requesting 10 LPT should be enough to get you started. The next major thing that I'm going to cover is registering as an orchestrator. And that's probably the last thing that I'll cover before we get to the GPU transcoding demo. So the main section that you're going to want to pay attention to here is the activation section in the activation subsection in the transcoding section of the public testnet docs. So there's a lot of text here, and there's a lot of information here trying to give you some background on how the activation process actually works at a protocol level. So I'll just give a brief summary here, and any additional details you can figure out just by reading the docs yourself. But the main thing that you want to know is that an orchestrator is active in a round of the Livepeer protocol if it's registered on chain, where registration consists of staking any amount of LPT and self-delegating. Anyone can register an orchestrator on chain. And then the second property is that it needs to be in the top 100 orchestrators with the most delegated stake. So in this early stage, it probably shouldn't be too hard to be one of the top 100 orchestrators with the most stake, but obviously this could change in the future. And then the other thing that's worth noting is that the way that activation works is that it happens on a per round basis. And at the beginning of each round, we lock in a new active set. So when a new round begins, the top 100 orchestrators with the most delegated stake are going to be locked in as the active set. And then at the beginning of the next round, the top 100 orchestrators with the most stake get locked in for that round. And the main implication here for people to keep in mind is that if you register as an orchestrator with a sufficient amount of stake to join the active set, you're not going to join the active set until the following round. So there's always going to be a 1-round delay. And that's as a result of how the active set rotation process works. So we can just take a quick look in the CLI wizard here of what it will look like when you go through this flow. So this node is actually already registered as an orchestrator, but we can still walk through the flow to give you a sense of what it looks like. So option 13 is invoking the multi-step become an orchestrator option. And these first few options should be pretty familiar to anyone that's run a transcoder in V1. So the first one is the reward cut percentage. So we'll just set this as 12. And the fee share percentage, which we'll set as 7. This next field is new. So this is the price per pixel field. And when you're registering as an orchestrator, you're going to want to set a price per pixel to charge on the network. But you can always change this later on. So it's not a big deal if you set a price per pixel when you're registering and you decide that you want to change it. The price per pixel is actually something that's advertised off-chain. So you won't incur any additional costs by changing it in the future. So for now, one other thing to note is that the format of setting this price per pixel is split into a number of pixels that you want to charge for, and then the price that you want to charge for those pixels, just to explain what you're about to see. So here, the default is 1 pixel. So we're going to be charging on a 1 pixel basis, and we're going to charge 1 pixel per way. And the last thing that we're going to do is we're going to set the publicly accessible IP and port that our node needs to register on-chain so that we're reachable by the rest of the network. So here, the node conveniently is going to try to automatically discover your public IP and use a default port that you should make sure to keep open. So for here, you can see the public IP that was automatically discovered by the node. So I don't even have to worry about figuring out what IP to use. And the second part is the default port, which is 8935. You can change this if you want, but there's going to be a default set by the CLI wizard for your convenience. And then once you finish those steps,
there was a good question in the chat about this step, which was if you're running separate transcoder processes talking to your orchestrator, and those transcoder processes are on different machines, do they need to be publicly accessible on the internet as well? And I think Michael shared back the response that no, the transcoder processes don't need to be publicly connectable from the open internet. They only need to be accessible from the orchestrator process itself.
Yep. So for the transcoders, I think that's right. And I think one way to think about it is that the transcoders are kind of an implementation detail of the orchestrator. So the rest of the network doesn't really need to be aware of any of the transcoders that an orchestrator is running. That's purely a concern of the orchestrator itself, and how it chooses to set up the architecture of its transcoder pool that it's connected to is up to them, and they do not need to be publicly accessible.
Cool, thank you.
Cool. And
and in the interest of time, to keep things moving too, we have some other topics to get to. So you can choose what's most important for people to see. But yeah, let's keep it moving.
Yeah, so I'm basically done with this portion. And the last thing that I was going to show is that if you were a fresh node, you would see a set of transactions being submitted to register yourself on the network. But in this particular case, the node is already registered, so it's going to prevent you from submitting those extraneous transactions. But I think this does illustrate the flow that you would go through using the CLI wizard to actually get activated on the network. And for additional details on these activation steps, I encourage everyone to go to the transcoding section in the public testnet docs. And if you run into any issues, definitely pop into Discord, ask questions as is needed. So that basically wraps up the high-level walkthrough that I wanted to go through, just covering some of the very basic steps that you're going to want to take in order to confirm that you can get registered on the testnet. And I think the next demo is the GPU transcoding demo that Michael is going to do. So Michael, do you want to take over?
Well, before we cut over to that, one thing I just want to point out for everyone is some of the flags and configuration options that we didn't show that are important, I guess, relate to two things. One is the flags related to this probabilistic micropayments setup, the method that you'll use to receive payments on the network. You as an orchestrator have a little bit of control and input into how frequently you want to get paid. And the trade-offs that you're making there are just more frequently that you want to get paid, potentially be paying a little more overhead in order to receive those payments, or if you want to get paid larger amounts at less frequent intervals, you might be blocking yourself out from users that don't have big enough deposits on chain in order to secure the payments to you. I don't think we have to get into all those details on this call right now, because the kind of software by default should use same limits that are competitive with the rest of the network. But I think that'll be probably a good kind of experimental area for there to be a lot of discussion around, maybe on the forum or in the chat, for example, going forward.
Yeah, so just a follow-up to that, we didn't cover it because there's a lot of details to cover, but if someone is looking at the public testnet docs, we do have a section dedicated to configuring your payment parameters, which covers a little more about the price per pixel details, as well as these ticket parameters. And there's an accompanying basic script that helps perform some calculations for you. That's pretty early and pretty rough, but it just seeks to get people started. But I think the story around the onboarding process for configuring payment parameters is going to improve over time, especially as people start playing around with it.
Great. All right, so now we've looked at kind of the basic, how you get a single node up and running and active on the network. Now we want to look at what it means to actually run GPU transcoders and concurrently mine cryptocurrency while you're transcoding on Livepeer. It's certainly not a requirement to do both at the same time, but it's an opportunity. And the more income you generate from your GPUs on the mining side, the more competitive you can potentially be on the transcoding side in terms of what you can charge to still be operating your infrastructure profitably. So another big topic, but I'll hand it over to Michael to show a demo of this in action and to have a little discussion around GPU, dual mining and encoding.
Hey there. All right. So for this demo, I took care already of most of the details that Yandin mentioned. Oh, I present now. Here we go. Do we see my screen yet? There we go. All right. So this is NVIDIA SMI. It shows us that we're running a Tesla K80. This is actually running in Google's GCP, Google Cloud Platform. So this particular GPU isn't the strongest GPU for mining, but it does do transcoding. I originally was not aware that we were doing a dual mining transcoding demo today, but luckily, yes, we indeed will be doing that. So we can jump over to this other tab here. It shows that I have ETH miner running. It's actually mining Ethereum on wattpool.net. It's only mining at 2.89 megahash, but again, this is a Tesla K80, so that's actually good for this particular GPU. In NVIDIA SMI, it shows the process name, ETH miner is running. Good. So there we know that it's actually happening there. Now we're going to go and actually bring up a BOT network. I built this one in Docker Compose. It also includes Prometheus and Grafana for metrics and statistics. So here we could bring it up. Oh, forgot it's going to want a password. Docker Compose allows me to bring up multiple containers representing different machines, all to function together in a single network. Now that was a lot that just scrolled by, but all that really matters is that all the system, all the parts are working. Meanwhile, okay, so now our network is sitting here. Livepeer network is ready to go. As Yandin mentioned, you need to expose ports. In my case, rather than exposing ports, I actually tunneled them back to my laptop over SSH, but in a production environment, you're actually going to expose them. So here we go. Let's start by streaming our official Big Buck Bunny source video into the network using FFmpeg. So here we go. FFmpeg is now streaming the video. We can go back to the tab with Livepeer running, and we can see stream started, segments are transcoded, submitted. Things are working. Now this is a text file, text log output that says it's working, but like, why should you believe me, right? Let's prove it. Now we can actually play over that, the same port that I had forwarded or exposed over the network. And this is the video. I don't know if this shows over the Hangouts connection. Can you all see this?
I can see it.
Yes. All right. So this is a transcoded movie that's actually running through the network that I just showed you. While this is going, let's jump over here and take a look at Grafana. Now, it's only been running a few seconds, so there's not really a lot of data here, but we can see the success rate graph. We can see the emerged segments, transcoded segments. I think we're set up to only go every 5 minutes. These usually end up being equal. There's a delay because of the sample time. This is the panel that we're working on. There's a lot more data that we plan to expose, and we're going to trim this down as well. But this is the initial version.
Is this scraped from a Prometheus exporter?
Yes.
And that's built into the transcoder?
It's not. It's actually... Here, let's go back there. First, I want to kill this because I hear it playing in my ears. Let's actually stop the network here. bring it down. The way that this demo is running, it's a Docker Compose, as I mentioned before, and I hope you can see the whole screen, but all the different pieces have their own entry in the services section. Now, there's an orchestrator piece, a transcoder piece, a broadcaster piece, and then below that, we have cAdvisor, Grafana, Node Exporter, and Prometheus. So Prometheus is actually running in its own container, but it scrapes data from the broadcaster and the orchestrator over their CLI ports. I think it's a CLI. Yeah, it is the CLI port. Does that answer your question?
Yep, fantastic. That's what I was looking for.
Is that kind of Prometheus script or process something that or container setup instructions, something that is documented and available for others to be able to drop onto their own test setups?
Yeah, that's a work in progress. The actual script to bring up the network is already in a pull request. It's going to be merged soon, and we'll be adding the Prometheus stuff that I'm running right here shortly afterwards, probably within a week or so. I realize there's one other thing I forgot to show, so let's get this running again. All right. While I was talking, I just started the network again, and I set FFmpeg to stream yet again. We see it going over here. Let's double check. We see that ETHMiner is still running, and take a look. It was transcoding at 2.89 before, and now we see it dip as low as 2.88. Here we see a share got accepted, so it's really actually mining. Oh, there we go, 2.84, 2.79. Fine, it dips a little bit lower, but the impact on mining while transcoding is extremely minimal. Last thing to show is here's NVIDIA SMI running, showing both processes touching the GPU at the same time. It shows us how much memory we're using, and we're not even going near capacity. So that's everything I have. Are there any other questions?
So the video encoding itself is not adding a lot of memory usage on the graphic card.
Video encoding right now is using 3.5 gigabytes, which is actually 3.5 gigabytes. It's not that much.
That's the hashing.
Oops, what am I talking about?
That's the hashing.
Yes,
So
I've totally read the wrong one.
200 megabyte then.
It's using from 2 to 120 megabytes. It's hardly anything. But also in this case, we have very small segments that we're sending, and that's what we'll usually be doing anyhow. If you were to send longer segments, it would need more memory, but the idea is short segments, and that's how it works.
Could you do us a favor and show us the NVIDIA SMI with daemon as a parameter, so that we see the encoder and decoder utilization of NVEC?
What exactly you want? You want to see?
Yeah, now at the end.
Yeah, no. This is how it works when you're using watch. You want --daemon?
No, just DMON.
Oh, daemon. I knew that. Here we go. Invalid. Why?
One dash. Weird.
No, I think it's no dash. NVIDIA daemon is one word, and then you don't need the watch.
Oh, I see.
Yeah. Yep. Come on.
There we go. So DEC is decoder utilization and ENC is encoder utilization. And you see there's still a lot of headroom. So you could potentially do like you have your own one of the two available chips here, right? And you could potentially do 8 times the current processing in video encoding.
Yeah.
Right, because with this demo, we were looking at one input stream at a time, but theoretically, when you're running your GPUs in Livepeer public network, you could, it depends which GPU you're running, but you could do from 2 to 8 or 10 streams at a time, depending on the pixel mass density of the individual streams and the encoding requirements on the hardware that you have.
And naturally, when you're doing more streams, it ends up taking a slightly larger toll on the mining if it's happening concurrently. but we're still talking about a minimal change here.
Great. So Michael ran through a great demo there pretty quickly, showing that this is possible. I'm sure people have some practical questions as they think about testing or setting this up. Now might be a good time for a couple.
What kind of price is this? I mean, if you were looking at this at a price setting to break even, what kind of price is appropriate?
Good question. So I have a little bit of a section on pricing later, but I think, are you asking like what you would want to
I'm just
earn
asking generally what some, like, don't hose yourself on pricing out of the gate is before we learn a little bit more about it. But it sounds like you're
Right,
going to later, so I can wait.
No, it's okay. I think it's a good time to address it. So one question is, are you going to be taking advantage of this concurrent mining opportunity, which if you want to be cost effective and maximize your income, you probably are, right? And so Philip, you have some good back of the envelope numbers. Maybe I hand it over to you to talk about, what you would expect to earn hashing per GPU per day, what the additional costs for transcoding might be, and therefore what you might want to charge for transcoding.
Yeah, so if we're talking about a comparable product, like a cloud computing service that offers you an API that you can just send as many streams to as you want to, and you get adaptive bitrate encoding out, then we are talking about really heavy pricing, like Amazon is there, like with about $3 per hour for a 1080p transcoding in multiple resolutions. And I think that if a miner would manage to have like 4 or 5 streams running on a single GPU next to his hashing, and he would earn, like, for all these streams together, like $1 per day, which would be like twice as much as what he's currently doing with hashing on that card. So if he would do it, then we would still be able to offer it for a price to the market that is 1% of the current AWS market price. Now, there's businesses out there that are going to be willing to pay much more for that. They're currently paying $3 per hour, and they, in some cases, do not even need a price drop there, as it already fits their business model. But there's that big pool of ideas that would require that processing heavy task, and they previously all dropped off the table from that market now with this new price paradigm, but it's a little unclear on where that market is going to settle and what they are going to find is going to be feasible for their business. So, but yeah, I'm gonna think we are going to multiply miners' revenue and even have an even higher impact on the profit margin, as they do not have to invest in new equipment really, and it's only the additional bandwidth requirements that come on top. And this is also heavily effective on the price. If you have access to really affordable fiber optic connections right now, then you will have a huge advantage to somebody who just pays more for it, because bandwidth really adds up, and it's like similar from a cost perspective than the actual processing in many cases. Some cases even more expensive.
Yeah, so that's a good overview of some of the market dynamics. I'll actually jump back to my presentation to talk about this bandwidth pricing as the next topic. Before doing so, any other quick questions on the GPU configuration from anyone? No? Okay, well, thank you, Michael, for walking us through that. And yeah, we have more time for Q&A towards the end. So I'm going to quickly share my screen again. I think hopefully everyone can see that. So Philip just mentioned bandwidth being a big impact into pricing. A little background, maybe to answer some of Tim's question, is your additional costs in electricity for doing transcoding on the GPU are pretty minimal to non-existent because you incur no overhead cost for additional electricity unless you're actually performing transcoding, aka if someone is paying you a fee to do that transcoding. So if you're already mining and hopefully mining profitably or close to profitably, you're not going to become unprofitable because you are Livepeer enabled. There'll be no impact. But and then if you are encoding, we've actually seen sometimes the electricity use going down in some circumstances, which is a little confounding, but it's because the hash rate decreases a little bit and that draws less power while you're encoding. But you'll be charging likely much more than what your electricity cost is. It's really actually the bandwidth where you have to make some pricing decisions, and that's because bandwidth you oftentimes have to buy and dedicate in advance, regardless of if you're doing work or not. Whereas electricity you're only paying when you're actually drawing it and using and doing the work. And so bandwidth becomes a big differentiator between nodes on the network because some people already have a lot of bandwidth pre-provisioned and is cheaply available, and they have excess bandwidth available. And other people host in data centers or regions where it may be more expensive or not as easy to add as you go and have to make bigger decisions about investing in bandwidth. So the first question there is, how much bandwidth do I need as an orchestrator on the network? And this is, the answer is, of course, it depends. And it depends how much work you want to do. It depends what sorts of streams you're encoding. But a good ballpark benchmark number is you want at least 10 megabits per second of dedicated bandwidth for every HD stream that you want to be able to encode at one time. And so a good way to think about this is, here's how much hardware I have deployed. Here's how many streams I could theoretically potentially encode at once. So if that was, for example, 100 streams, then you would say, okay, then I need 1 gigabit per second of dedicated capacity in order to be able to encode 100 streams at once. That might be enough to saturate 2 to 3 mining rigs or more, depending on which hardware and how many cards you're running in a specific mining rig. These are just ballpark back of the envelope numbers. But it's also worth noting, just because you've deployed the hardware doesn't mean that there are that many streams on the network that you'll have the opportunity to compete and win. Also noting that you have to stake and provide enough security in order to encode these streams and have the ability to compete to win the available work. And so what you're going to want to do is basically manage your bandwidth purchase and your your bandwidth purchase in relation to how much hardware you've deployed and what sorts of demand you're seeing that you have the ability to fulfill on the network. And if you're really operating in an optimal way, you'll be able to add more bandwidth as you go, and you increase the amount of work that you can do based upon growing demand to use the Livepeer network, rather than making huge dedicated investments up front prior to there being significant demand. And then the question is, how much does it cost to buy this bandwidth? And the answer there is, it really depends where you host. The bandwidth prices vary tremendously, even within cities and regions, just depending on the data centers, providers, and the peering arrangements. So it can range from 10 cents per megabit per month to $1 per megabit per month, or even more in some locations. And so this really goes to show that those who can find reliable and affordable bandwidth that you can allocate efficiently will be best positioned to compete with affordable pricing on the network. And now if you think about using the Livepeer network from the user's point of view, you can see why this is important. Someone who is competing for their work at 10 cents a megabit per month obviously has a lower cost basis and can afford to offer the service for less than someone who needs to pay $1 per megabit per month. and that results in a more cost-effective Livepeer network that's more attractive to potential users, that leads to more streams and more fees for everyone to compete to win. So that's my quick overview of bandwidth. The last topic I want to do is just recommend some practical setups and paths to getting started as Streamflow launches. Before I do that, any questions on bandwidth? No, okay, that was the simple bandwidth overview. Glad it was clear. Finally, just like I said, the practical path to getting started. So of course, it's interesting to think about deploying thousands of GPUs and dual mining, and you're going to be able to transcode 20,000 streams of video. And as Philip had mentioned, people are paying between 50 cents and $3 per hour per stream. So you do the math and see how big those numbers are and how much money you're going to earn. But of course, there's not tens of thousands of streams flowing into Livepeer on day one. And so deploying hardware just for anticipation of Livepeer all at once, likely wouldn't be the best financial decision unless you have a really profitable mining operation or alternate use for those GPUs as well. So, for a kind of independent node operator or orchestrator who wants to make a small investment to get started and learn how to operate and grow and scale with the network, what's something that you can do that might let you operate for real, let you compete to win work on the network without dedicating a ton of resources up front. And I think it looks like the base case. It looks like deploying maybe a single GPU mining rig with 4 to 8 GPUs in it. I think you want to deploy this in a data center that has good peering, reliable internet, and a couple hundred megabit per second of dedicated bandwidth at the minimum. I think you want to run an orchestrator node on the CPU that's part of that rig, and you want to get comfortable dual mining cryptocurrency on those GPUs. So mine Ethereum, for example, like Michael showed, if you can do it profitably or close to profitably, or look at other coins that may be available. And then you want to experiment with market pricing on Livepeer as Streamflow launches, as many test streams and real user streams start to flow through. You'll observe your ability to win work versus the other nodes at the price points that you think work for you. And then as demand grows, hopefully you have the ability to add bandwidth as you go, and of course consider adding more capacity if you want to compete to win more work as you go. I think this is definitely an upfront investment if you're not set up as a GPU miner already. But I think this is, it's not a trivial amount. Setting up a mining rig that might cost a couple $1,000. Hopefully the LPT that you may have been kind of earning over the last year is helpful in kind of reinvesting into this. But it'll let you validate your setup, your ability to operate and compete, learn what it means to operate on this network, gain expertise in Livepeer, and be well positioned to scale out and help the network as you go. So nothing groundbreaking here, but it's just kind of making concrete what a single starting point might be that gives you the ability to grow and scale out beyond. Another option here is that there are existing GPU cloud providers. I think the public clouds are going to be cost prohibitive, so renting in Google or Amazon or Azure is an option, but I think it's unlikely you'd be able to profitably compete with those who are deploying on hardware into data centers. But there may be people who mine, who have GPUs that you'd like to partner with and do maybe a kind of one-off arrangement, renting GPU access from them, for example. So that's another approach you can take. So that's basically it on my end. I think that's a lot of the core content I wanted to share. We're coming up on the top of the hour, but glad we have a little time left for questions anyone has that we didn't cover as we think about getting started to run infrastructure on Streamflow.
Yeah, I just want to add that those who basically have GPUs in infrastructures that have access to fiber have the big advantage now. And in many cases, you do not have to secure a few hundred megabits dedicated just for you, but get a metered traffic offering where you should just make sure you're not paying too much for the runtime. And we're going to follow up with some more data on what this means, like how much data is being produced over a certain time, that you not have to look only at bandwidth, but that you can also look at gigabyte traffic pricing and can decide on that.
Any additional questions?
So not a question, but I know that there's a few existing transcoders on the call, and that many of them might be planning on running orchestrator nodes once the Streamflow upgrade happens. If you recall the dashboard that Michael showed during his demo, that included some basic transcoding performance metrics. Something that wasn't shown there was a very basic payments dashboard as well. So I think in the next few weeks, we'll have some of this tooling available so that you can try this stuff out yourself. But once that becomes available for anyone that's trying it out, if you have any opinions or thoughts on the metrics or information that would help you better operate efficiently on the network, definitely provide that feedback, and all of that is welcome, because what we're going to put out initially for that tooling will be fairly basic, and the plan is to just improve it based upon what people want to see and what people feel like will help their operation when they're running on the network.
Yeah, and if you have any questions that that you want to ask us individually, please feel free to come into our Discord or reach out to us individually. We're always happy to help any infrastructure provider in the community to set up.
I just grabbed the screen really quickly because Yandin mentioned the payments metrics. I don't know if this is exactly what he's talking about, but this is the basic payments overview dashboard. Is this what you had in mind, Yandin?
Yeah. So this is pretty basic right now. So this just shows a cumulative total over the lifetime of the node. You can imagine that you might want other things as well, but that's the type of feedback that will be helpful as people start exploring it on their own.
Yeah, I just thought I'd show it real quick. So that's that.
And when you say you're including this dashboard, you're referring to like the JSON schema to generate the Grafana dashboard, correct?
That's correct.
Okay, thank you.
Great. To the point Eric was just making in terms of reaching out to us individually, a lot of kind of miners and infrastructure operators have preferred just to kind of be in small private Telegram channels or Discord private channels to get into the weeds and the details and debug specific setups and talk about specific hardware. And as he was saying, like, we love doing that stuff. We love learning about different setups, what hardware works well and what networking setups work well and stuff. So don't be shy. Please reach out, and happy to talk privately as well.
Yeah, like I was in a Telegram chat. I was in a Discord chat with somebody for like 3 hours yesterday, helping them debug different things. So very happy to help anybody do this.
I would be interested to ask the participants if someone is here who is already prepared to do the switch to GPU transcoding. So the silence means no, nobody is.
I know there are people on now or who have been on for part of this who have certainly talked to me about intending to be ready to do that, but we got a month to go, so time to get ready.
Okay, cool.
Great. All right, so we're an hour in. I think this was a great call in terms of being able to share this content, but yeah, don't hold back on questions or follow-ups. We're around. we got this recorded, so assuming all goes well, we'll have that online for everyone who couldn't join, and look forward to working with you all soon as we push for Streamflow.
Thanks, Doug.
Thanks, Doug. Appreciate it. Bye.
Thanks, everybody.
See you later.
Bye.
Thank you, everyone. Take care.